Okay, this is AP Stats. I'm going to do a quick 8.1 summary. Ideally, at this point, you would have actually read the actual section and gone through the examples, because I am not going to do the examples to try to keep this video short. So in any case in here where they actually had an example, please make sure you actually go through it, understand how they got the solution, what the problem was, so on and so forth. I'm only going to do the check for understanding question that is on slide number 14. And there's only 3 questions on here, so it's going to go pretty quickly. I'm trying to keep this video short. So really quick as a summary, to estimate the unknown parameter, start with the statistic that provides a reasonable guess. The statistic is the point estimator. Okay, so there's your vocab word. For the parameter, the specific value of the estimator that we use gives a point estimation for the parameter. Okay, so confidence interval, which is what this entire chapter is going to be about, uses sample data to estimate an unknown population parameter, because sometimes you don't know what it is and we need to actually find it, with an indication of how precise the estimation is and how confident we are the result is correct. A confidence interval gives an interval of plausible values for the parameter. Okay, so they can be anywhere between the point estimate is going to be your middle, and then plus or minus your margin of error. And then this actually turns into your statistic, plus or minus your critical value times your standard deviation of the statistic. Okay, so your point estimate ends up being your statistic, and your margin of error is really just this part right here. I'm going to highlight this. So your point estimate is like your statistic that you're going to be using, and your margin of error, plus or minus, is the same thing as your critical values multiplied by your standard deviation of the statistic. Okay, and then to interpret, this is the part where you guys have the most problems with, the confidence interval. We say we are C% confident, so usually we do like a 95% confidence interval in here, that the interval from blank to blank captures the whatever parameter and context we're talking about. Okay, and then be sure that your interpretation describes a parameter, not a statistic. And then a confidence level, which is completely different than a confidence interval. Okay, so those two are very different from each other. This is your confidence interval, and then this one is your confidence level. Okay, is the success rate of the method that produces the interval. If you use a 95% confidence interval often, in the long run, 95% of your intervals will contain the true parameter value. You don't know whether a 95% interval calculated from a particular set of data actually captures the true parameter value. But over the long run, 95% will capture the true parameter value. Okay. Other things being equal, the margin of error of a confidence interval gets smaller as the confidence level decreases. Okay, and the sample size n increases. All right, those are your two that go with the margin of error. And then remember that the margin of error for a confidence interval includes only chance variation, not other sources of error like non-response bias or undercoverage. All right. Okay, so that's a quick review of 8.1. Please read it and please go through the examples. I'm going to hop over to slide number 14. Sorry, this is not in your slides because it is in your book on page, where is it? On page 488. So if you wanted to get this down, by all means, go to page 488, and there's your summary. Okay. Okay, check for understanding. So in this case, how much does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs, 95% confidence interval for the population standard deviation. Sigma is 2.8 to 7.55. Okay, so the first one says interpret the confidence interval, which is what we're going to do first. So for number 1, okay, it just interpret. It doesn't, you already have the interval, right? you have it from 2.84 to 7.55. So you're not trying to find it in this case. You already have it. It's just interpreted. So that goes back to your interpretation on here, right? Interpret a confidence interval. We say we are blank % confident that the interval from blank to blank captures the whatever parameter we're talking about in context. Okay, so we are 95% confident that the interval from 2.84 to 7.55 captures the true proportion. Let me just double check. Captures the population standard deviation of fat content of brand X hot dogs. Okay, that's it. Okay, so we're just 95% confident that the interval from 2.84 to 7.55 captures the population standard deviation of the fat content of brand X hot dogs, because we're talking about the population standard deviation here. Okay, that was the confidence interval. The confidence level, number 2, is just a little bit different. Okay, confidence level is from here the success rate of the method that produces the interval. If you use 95% confidence intervals often, in the long run, 95% of your intervals will contain the true parameter. You don't know whether the interval calculated from a particular set of data actually captures the true parameter value. So we say, like on page, I think it's on page 483, I think, interpreting confidence level. It is, okay, if we take many samples, okay, so if we take many samples, approximately 95% of them, out of all these samples, 95% of them would result um, 95% of the intervals, actually, I should probably write that, 95% of the intervals, there you go, okay, would capture the population standard deviation of the brand X hot dog. Okay. We take many samples, about approximately 95% of the resulting confidence intervals. Sorry, I need to add this in here. Confidence intervals would capture the population standard deviation of brand X hot dogs. Okay. And then number 3, so that's your interpreting confidence levels. True or false? The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Justify your answer. It's actually false, okay? Because the best way to say it is, it gives a set of plausible values. So it's not exactly true. The best way I can interpret this one, because the book actually did a really good job of this, of explaining this one really quickly. Actually, no, the slides did. Slide number, oh, poopy, I don't have it open. Okay, the only thing I can say to this one is it's false. Okay, once the interval is calculated, okay, it either contains, so there's really just two choices. It either contains the standard deviation that you want, or it does not. All right, either of the two. So once it's calculated, then it either does or does not contain your standard deviation. Okay, those were the three, and this is probably the shortest video that I've ever done. Please actually read the section 8.1 before you come to class ready to do the homework problems. Thank you.